After the discovery of the quantization of energy, it was clear that the atomic model needed to be changed. Now, the old atomic model had a nucleus and then just some electrons floating around in a big cloud randomly, or at least that's what they thought. And with the discovery of this energy quantization, it became clear that that was not what was happening. And a big help to help scientists see what was going on was the emission spectrum of hydrogen. So here is the emission spectrum. The emission spectrum is when I heat up hydrogen, these are the wavelengths that it gives off. And I also put this up here, even though I'm not really going to use it that much, is the absorption spectrum. So these are the wavelengths that hydrogen takes in. So now that I know about the quantization of energy, where something either gives off or absorbs energy in particular amounts, this really helps to illustrate that that is in fact true and is what's going on. But anyways, they use this spectrum, and if you take any sample of hydrogen and heat it up, this is the emission spectrum you're going to get. And what that's telling us is that those electrons in hydrogen have a particular set of energy associated with it. It doesn't have a random energy. So, I probably shouldn't have erased that brilliant drawing, but obviously this is not what's going on. If this were true and electrons just had random energy, then I would have a random set of lines, because each electron, it would get hit by something, or it would absorb a certain amount of energy, and it would go arbitrarily up, or it would just be very arbitrary what that electron's energy would be. But that is obviously not what's going on here. They've all got this wavelength, this wavelength, this wavelength, and this wavelength. So a guy named Bohr came along and changed the idea of the atomic model. He set it up where the nucleus was still the center, but instead of having all these electrons just orbiting around randomly, he said that the electrons only inhabit particular orbitals. They orbit at a certain distance from the nucleus, and not just at any distance. So he's saying that, and I guess I don't really mean distance. He really meant distance, but his model was not correct. They don't orbit in circular patterns, but that's not really important. The idea is that electrons have particular energy orbitals. Just think of it as an amount of energy that an electron can have. It can either have this amount of energy, or this amount of energy, or this amount of energy, but it cannot have, let's say, this amount of energy here, or this amount of energy. So that's the idea. It has only a particular set of energies that the electron can possibly have. And these lights help support that. And these emissions are given off when an electron is heated and it goes up to some energy state. Let's say it goes from 2 to 5. It's orbiting 5, and then it needs to come back down to 2. Now, because of the conservation of energy, it doesn't just disappear, and it's not going to be able to go back down to this orbital with that much energy. So what happens is that it ends up giving off photons, or light. So it gives off that energy, and then it's able to come back down. So the higher the energy level, the more energy it has to give off. So this also helps to lend support to that idea, because these lower energy levels, the wavelength is longer, but then as I get to higher and higher energy levels, the wavelength gets shorter and shorter, which means that the frequency is increasing. And if I remember this, so if the frequency is increasing, then the change in energy is increasing. Actually, I can calculate what that change of energy is with the wavelength. Well, let me show this here first. So I know this, I can just divide out and solve for v, or not v nu, whatever, same thing. Oh, I forgot the h. Well, it doesn't really matter what order it goes in, but I like order. So we can use this to calculate the change in energy. So, and also that should just make intuitive sense. So as I have more and more energy, the wavelength gets shorter because of the increase in frequency. What else? Is there anything else? Not really. I mean, you can get all kinds of different wavelengths, and the wavelengths just depend on from what it just depends on the change in energy or the change in orbitals. I can go from 5 to 2, or from 4 to 2, or from 3 to 2, but I can also go from 5 to 4, and that would have a different wavelength. Or I can go from 5 to 3, and that would have a different wavelength. So that's where all these different wavelengths are coming from. And oh yeah, one more question I guess that might be asked, and that is, well, if hydrogen has one proton and one electron, why are there more than one wavelength that's being emitted? And that is because when I have a sample of hydrogen, there are a lot of different hydrogens in there, and they're not all going to have the same energy level. Theoretically, if I was able to isolate one hydrogen like this, and then do the same experiment, I would only get one wavelength and that would just be whatever energy level it happened to be going to. But I would only get one emission line. But since I'm not really sure if you could isolate one by itself. I mean, maybe, but I think I have seen where they have isolated one before. But I mean, that'd be a big pain. But anyways, that's theoretically what would happen. Maybe they have tested it, I don't know. I'm not going to bother looking for it, but that's pretty much the most important part of Bohr's theory, is that these electrons orbiting, they have a set amount of energy, and they either must gain enough energy to go to the next level or lose enough energy to come back down, but they can't go in between. That's why we have the same set of wavelengths every single time I do this emission spectrum. They have always a set amount of energy in each orbital. And why that is, well, that will be better explained in the future when, what are those guys' names? Heisenberg and Schrödinger go ahead and come up with the quantum mechanical model, basically kind of expanding on Bohr's idea of orbitals, but then kind of coming up with the rest of the pieces to kind of make to put a picture together that makes more sense, because he came up with this idea that it was kind of like a solar system, and they orbited in circular orbits, and it just didn't work. He got it to work for hydrogen, but then when he tried to apply it to something else, it didn't work, and then he had to do some other stuff to make that work. But it just became clear that obviously something was just not correct here, that they were missing something in it. It took Schrödinger and Heisenberg to come up with that next step and take the theory further.